Okay, now my expectation is that you've all done transformations in grade 11. So what I'm about to do with you isn't brand new. The depth to which we're going to take this might be a little bit more than what you're accustomed to. Some of the terminology that I'm about to use may be a little bit different from what you're accustomed to, but I'm going to hope that you're going to start phrasing things for this the way that I am phrasing them. Okay? Try to learn the language that I am teaching you for doing transformations. So if we had a polynomial function like this, as your typical polynomial function, all of these other parameters could change the way that function looks. So that a in the front, that k inside the bracket, that d inside the inner bracket, and that c on the end, they all do something to the function. Let me describe them one at a time. And again, this should be a refresher for you. This should be stuff you did before back in grade 11. The a, the number in the front, gives you what's called a vertical compression or stretch. Some people call it vertical expansion. I don't mind that terminology, but I usually say vertical compression. And by the way, you're welcome to use my abbreviation for that, which is VC for vertical compression or VS for vertical stretch, right? You're welcome to use that abbreviation. If the number in the front is less than 1, such as 0.5, you get a compression. Kind of makes sense, right? If the number is less than 1, then you should be making it smaller. So that's what vertical compression does. If the number is greater than 1, that a is greater than 1, then you get a vertical stretch, such as 6x squared. So this is an example of a vertical compression. That's an example of a vertical stretch. Okay? Notice that the number is just in front of the usual x squared. So 6x squared is the function that we're dealing with. The other thing that the a can do is give you a reflection on the x-axis. Okay, so if I had a negative a, so for instance, like what you see here, the negative is on the front, then that would be a reflection on the x-axis. We're going to talk about what each of them affects in a minute, whether it affects the y coordinate or the x coordinate. But yes, it's a reflection on the x-axis. Now the k is what I'm pointing to right now. What does the k do? Well, remember, the A gives us a vertical compression or stretch. Well, the K gives us a horizontal compression or stretch. But the problem with the K is that it's kind of the opposite of the vertical. So if the number is more than 2, such as a 2 here, then you actually get a horizontal compression. And if the number is less than 1, such as 0.5, you actually get a horizontal stretch. So it almost seems backwards. It almost seems like you turn things upside down when you compare them to a vertical stretch or compression. The bigger the number is the more the compression is. And that's because the compression factor is always 1 over the value of the K. Same thing for the stretch. The stretch factor, and we always talk about by a factor of this or a factor of that, is always 1 over the value of the K. So because it's 1 over, it makes it get bigger if it's less than 1 and smaller if it's greater than 1. Okay, we'll get some more examples of this in a second. If the K value is negative, you're going to get a reflection on the y-axis. Okay, so for instance, I notice the difference where I put the negative. When it was a reflection on the x, the negative was in front of the bracket with the x squared in it. This one is right next to the x before I cube it, and that's a big difference between the two of them. Okay, how about the d on the end? Not what's not on the end, the d inside the bracket. If that d is like a +3, I'm actually shifting. It's called a horizontal translation. You're actually shifting or translating to the left by 3. That's what this is doing. If it's a minus inside the bracket, you're actually shifting to the right. That's why horizontal is so sometimes difficult to get your head around, because it's always the opposite of what you expect. A plus shifts to the left and a negative shifts to the right. A number greater than 1 gives you a compression. A number less than 1 gives you a stretch. I know that doesn't sound right, but that's how it is with horizontal. Horizontal kind of makes everything backwards. Then we have the C on the end. That C makes the function shift or translate up or down. It's called a vertical translation up or down. And by the way, in terms of abbreviations, I should have mentioned, I mentioned that you can use reflection in the x-axis, sorry, vertical compression, vertical stretch, horizontal compression or stretch. I'm okay with HC and HS. You don't have to write the word out every time. You can just use those abbreviations. For translation, which is horizontal, I can take I can take an HT, horizontal translation, but you have to tell me in which direction. So you have to say either right or left if it's a horizontal translation. If it's a vertical translation, you have to tell me whether it's translation. Where's it? Oh, I haven't got the vertical translation yet. Vertical translation is down here. So vertical translation, which you can use as VT, you have to tell me whether it's up or down. That has to be part of how you describe it. Okay, hopefully I haven't left anybody behind yet. Let's put this all together now for this particular function. Minus 2, 0.5, x plus 1 squared plus 3. Bearing in mind that you're supposed to have done this before, can anybody tell me any of the transformations that are going on with this equation? So minus 2, 0.5, x plus 1 squared plus 3. I have a list of them under here, and I'd like to reveal them gradually. Okay? So who is first? Looks like Jeremiah and Janiyah both raised their hands. Let me take the first person up, which was Jeremiah. Jeremiah, give me any translation that you can think of based on that equation. Okay, let's see if I have, okay, I do have them all, so I'll accept that, you're right. And Janiyah, what else do you see? Good, both of those are right. Both of those are absolutely right. Let's see if any of these are, okay, so no, I'm kind of giving away stuff that we're not ready for yet. Okay, so I've got Jeremiah and I've got Janiyah giving us 2. What else can you see there apart from those 2 people? Can anybody else? Okay, I see something in the chat here. Are we allowed to say reflection across the x-axis? Of course you are, Noah. Absolutely. And it is a reflection across the x-axis. Yes, it is, because this a value is negative. In fact, that was the first thing I had on my list, reflection on the x-axis. So well done. Horizontal stretch, you say. I agree. But when you say horizontal stretch, you have to also say, Kayla, by a factor of something. Can anybody tell me what that factor is? By a factor of what? How big of a stretch it is? It is a horizontal stretch. So it's by a factor of 0.5? No, it's not, because it's always 1 over k, remember? So it's not a factor of 0.5, it's a factor of 2. Thank you, Riley. Let's see what else we have under here. So vertical, oh, we haven't got, so you guys have left out some stuff. There's a vertical stretch by a factor of 2. That's what this 2 in the front does right here. It's a reflection on the x-axis, right? That's what the negative does. Notice I'm using another abbreviation here. Vertical stretch is VS, and by a factor of is BAFO. You're welcome to use that. Okay, Kayla's asking, how come? Okay, remember I said to you that, are you asking how come for what, by the way? For the horizontal stretch or for the vertical stretch? Which one are you asking about, Kayla? Horizontal, yeah, that's the one that's a little bit harder to wrap your head around. So remember we talked about the k here. The k is this part inside of the function, right here. Now, it's always 1 over k to know what the factor is. So in this case, it will be 1 over 0.5, 1 over a half, in other words. 1 over a half is the same thing as 1 multiplied by 2 over 1. If I'm dividing by a half, it means multiplying by the reciprocal of a half, which is 2 over 1. And that's why it's not a horizontal stretch by 0.5. It's a horizontal stretch, Joel, by a factor of 2. There we go, by a factor of 2. All right. Joel, does that make more sense now? Why it's a factor of 2? Not, sorry, a factor of 2 and not 0.5. Okay, great. All right, so but we got some more things as well. Somebody else mentioned that there's a horizontal translation 1 to the left. I think it was Janai or Jeremiah, I forget which one it was. But yeah, that's part of it. And then the last part of this is, and somebody else mentioned this, a vertical translation of 3 up. So I'm using all the abbreviations here that we talked about. Vertical stretch, VS, BAFO means by a factor of, horizontal stretch, HS, by a factor of 2, horizontal translation, 1 to the left, vertical translation, 3 up. Okay, great, great. Now, here's the other challenging part. Do we know which of the 2 coordinates is affected by each one of these things, which we're going to be getting to in our table of values shortly? Do we know if we had an X and a Y, right? Let me erase this here. If we had an X and a Y, do we know what would happen? Which of these affects the X coordinate? Because it is as specific as that. Let me start with the first one. Reflection on the X-axis. What does that affect? The X or the Y? Does anybody know? Reflection on the X-axis. Does it affect the X coordinate or the Y coordinate? Do we know? It affects the Y. Quite right. Quite right. How about the vertical stretch by a factor of 2? Does that affect the X or the Y? The vertical is kind of a giveaway, right? Think of the vertical axis. When you hear vertical, always think of which axis is vertical. So the vertical axis is the X-axis. Is that right? Vertical axis is the Y-axis. So when you hear vertical, it does mean we're talking about the Y's. Okay? Well, that would suggest horizontal must be the horizontal axis. So what do you think the horizontal stretches would affect then? It affects the x's. Good. How about the horizontal translations? What do you think that affects? The x or the y? It affects the x because it's horizontal. And how about the vertical translation? What does that affect? The x or the y? Perfect. The vertical axis is the y-axis. So what does this all mean for a typical table of values? Well, I'm going to show you right now. I am going to, first of all, and I'm going to be asking you all individually to help me out with this, but let me show you the first few first. These, by the way, this is the same equation that we had on the previous page. I haven't changed anything. It's the same equation that was here with all of these features. Reflection on the x-axis, vertical stretch, horizontal translation, vertical translation. It's the same equation. So let's see how the original function, which is y equals x squared, how it gets transformed into this new function. It's still something squared, but before you square it, you add 1 to it, you multiply it by 0.5, you multiply it by -2, then you add 3. Well, before we transform, let's just put the typical values that we get from a y equals x squared table of values. So I would assume you'd know this, -3 should give me +9, -2 should give me 4, -1 should give me 1, 0, 1, 4, and 9. So that's before the transformation. I haven't done any transformations yet, right? That's just my original y equals x squared line. And I could draw that over here. So here's my starting point, across 1 up 1, across 1 up 1, across 1 up 3. We talked about step pattern the other day, 1, 2, 3, across 1 up 3, and across 1 up 5. 1, 1, cross 1, 1, 1, 2, 3, 4, 5. Here. Cross 1, 1, 2, 3, 4. No, that's not right. It's right here. Let me fix that one. I knew it sounded a little odd. Okay, so here's my graph. Original graph, before any transformations are done to it. Okay, now let's transform it. Let's do all this vertical stretch and horizontal everything. Now, if you go back to the previous page, let's focus on the things that affect the x's. The horizontal stretch the horizontal translation. Just those two things. Just those two things affect the x's. Everything else affects the y. This affects the y, this affects the y, and this affects the y. The stretch and the translation affect the x. Now, does it matter which one I do first? The answer is yes. Stretches and compressions and reflections come before translations. According to what this says I should stretch by a factor of 2, which means multiply by 2, by the way, and then translate 1 to the left. That's what I'm going to do with each of my x's. I'm going to multiply them by 2, then I'm going to subtract 1. Okay? Stretches and reflections and, well, stretch and reflections come first, stretches and compressions come first, translations come next. So I'm going to multiply by 2, subtract 1. So let's do that to all the x's. The first x was minus 3. So minus 3 times 2 is minus 6. Minus 6 minus 1 is minus 7. Okay? I'm going to do the same thing again to the minus 2. Minus 2 times 2, remember I'm multiplying it by 2 because of the horizontal stretch, is minus 4. Minus 4 minus 1 is minus 5. I'm going to do 2 more. Then I'm going to ask one of you for the next 2 numbers. Minus 1, multiply that by 2, which is minus 2. Then I minus 1 from that. So that's minus 3. Now, after a while, you're going to notice a pattern, right? If these numbers, minus 3, minus 2, minus 1, etc., then for the x values, you should see a pattern. Does anybody see a pattern for these x values? You notice anything? So that might help me to get the next one without doing a lot of math. Minus 7 went to minus 5, then went to minus 3, and then increasing by 2, Keonta says, add 2 every time. You're absolutely right. You're absolutely right, right? So if I'm going to go from minus 7 to minus 5 to minus 3, then what should my next number be after that? It should be minus 1. Good. All right. Now, let's see if we can follow that path. Don't put any more answers in there, please. Why do I have Travis here? Did we just ask Travis a question? I probably did, eh? All right, we'll remove Travis. Looks like we did. Let me ask somebody to tell me what the next 3 values are, just simply following that pattern. Ava, it's your turn. Can you help us out with that, please, Ava? The next few terms after the minus 1. So Ava says 1, 3, and 5, and I absolutely agree with that. But if we wanted to check, we could take the 3, multiply it by 2, which is a horizontal stretch, and then minus 1 still gives us 5. So we're good. Thank you, Ava. Now let's get to the y's. Let's see what happened to the y's. The y's had a vertical stretch, a reflection on the x-axis, and a vertical translation of 3 up. Now, the vertical stretch and the reflection can be done together. I can multiply, because it's a stretch, I'm going to multiply. I'm going to multiply each value of x. It says by a factor of 2. I'm going to use minus 2, because that takes the reflection and the stretch in at the same time. So I'm going to go ahead and multiply each y value by 2. Then according to this, it says vertical translation of 3. Then I'm going to add 3. So not by 2, by minus 2, sorry. Multiply each y value by minus 2. Then I'm going to add 3. Okay, so let's go back to the table. So the first y value was 9. 9 times minus 2 is minus 18. Minus 18 plus 3 is minus 15. This doesn't follow the same pattern like the x's, so let me just warn you about that. Let's try the next value of y. The next value of y, multiply by minus 2 again. So let me just think that would be minus 8. So minus 8 plus 3 is minus 5. Everybody caught that? Does that make sense? We're checking with the room on that one. Want to make sure no, right? Let's see, no, let's see. Rachel, how about you? Does that all make sense so far? Do you see how I got those values of y? Okay, good. All right, so let me ask somebody to see if they can give us the next value of y. We'll take Ava out. I need someone to tell me the next value of y. So we started off with 1, right? So we're going to be looking at this value of y and seeing what happens to this value of y. Rylan, it's over to you. Can you give us, Rylan, are you there? Perfect. Do the same thing I just did with the 9 and the 4. Do that same thing with the 1, please. Same thing with the 1. If you need some help, you let me know, by the way. I multiplied each of those y, so you're getting 1 when you do that. And let's see, so that's -2 plus 3. Oh, okay, yeah, that is 1. Good stuff. Thank you, Rylan. All right, so everybody following along. This is all making sense. All right, let me take Rylan out. I'm going to be asking somebody to do the same thing with 0. All right, say multiply by -2, then add the 3. That's Neil. Neil, your time. Over to you. Multiply by the -1. Okay, I'm confused. Oh, sorry. Hold on, please, Neil. What are we multiplying? Each of the y values, Kayla. So let me go back and look at the first y value. So you see my table of values there? My first y value was 9, right? Isn't that true? Yeah? Kayla? First value was 9, right? Okay. And each value of y, look at what this says. We have a vertical stretch by a factor of 2 that affects the y, reflection on the y-axis, that changes it to negative. So whatever answer we get from this, we multiply it by a negative to get the result. But then we also have to add on the vertical translation up by 3. So we multiply each y value by -2, then we add on 3. So let me go back and show you now. All right? Sorry. So we took the first y value of 9, multiplied by -2. You tell us what that is. What's 9 times -2? What is that? Let's add 3 to that. That's where I got that -15 from. Let's try one more. Let's try one more. Good. And we did the same thing with the 4. Multiplied 4 by -2, which was -8. Then we added on 3, which gave us -5. Okay. All right. You're welcome. And I think, where was I? Where was I? Neil, your time. Neil, can you give us the next one, please? So next one meaning what happens to the 0? The 0 is the next y value. What happens to that 0? Neil. Neil, are you there? Okay, you got 3, and I agree. Now, we really don't have to do any more work on this one because these y values we already have. When it was 1, it was 1, so we can put that one back. When it was 4, we had 4 before it was -15. When it was 9, it was -15. Okay? So we already have y values worked out, so we really don't need to do anything more than that. So I can go ahead and draw my graph now. -7, -15. I'll use a different color for this one. -7, -15 is somewhere around here. This graph that we're about to draw should look still quadratic, but it should have been stretched and shifted and a bunch of other things to it. And then -5, -5. That's that point right there. And then -3, 1. -3, 1 should be about here. And then -1, 3. -1, 3 should be around here. And then 1, 1 should be about here. And then 3 -5 should be about here. And 5 -15 should be about here. Folks, don't laugh at my drawing, okay? I can see some of you grinning already and making fun of my art. Actually, that's not too bad at all. That's not the worst I've ever drawn. Trust me, I've drawn a lot worse than that. I missed one of the points up at the top there. All right, so sorry about that, folks. But this function, right, has all the features that we just talked about. It's been reflected on the x-axis. You can see it's now upside down, right? It's been flipped over onto the x-axis. right? It's been shifted up by 3. You can clearly see that. It's gone up by 3. After we reflected it, we lifted it up by 3. It's horizontally wider than it was before. Look at how, compared to the first graph, remember, it had a horizontal stretch by a factor of 2, right? So it's been stretched horizontally, it's been pulled horizontally that way. Well, you can't see my hand, so that's pointless, Mr. Kamak. It's been stretched horizontally. It's also been stretched vertically. So it's been pulled down as well, right? Vertically, according to all the things that we said before, right? So you can see the reflection on the Y, on the X, sorry. You can see the vertical stretch, you can see the horizontal stretch, you can see the translation of 1 to the left, right? We should be able to see that as well. It's been shifted 1 to the left. So all the things that we said were going to happen to it did happen to it. It all hopefully makes sense. Now, let's see how you do with this one. Oh, sorry. This is the Desmos version of it. I should just mention that. Let's get to, we'll talk about this one a little bit later on. I want to get to this one very, very quickly. Let's talk about transformations that have taken place with this one. All right. I'm going to ask one of you for any transformation that you think is, let me take Neil out, by the way. Think of all the transformations we talked about before: vertical stretch, vertical compression, horizontal stretch, horizontal compression, reflection on the X, reflection on the Y, all of that good stuff. All right, so Kristen, it's your turn. So think about all the things that we just talked about and tell me if you can figure out any of the various things that we just mentioned. So Kristen, over to you. So what is a horizontal stretch, horizontal compression, horizontal translation, vertical translation? Think of all of those things. And you can use the abbreviations, the HT and the VT and all that good stuff. Give me any of the transformations that you think is going on with this equation that's on the smart board. Over to you, Kristen. So any one of them that you can see. Okay, so you see VT down by 8. Completely agree with that. In fact, I think that's the first one on my list. Let me see if that's the first one on my list. Hang on. Nope, that's not the first thing on my list. But it's there. It's there. Well done. So VT down by 8. That's good. Let's get another one. Thank you, Kristen. Let's get another one from... I'm not going to tell you how many there are, but I want them all. Noah. Noah, can you give me another transformation that's going on, please? Another transformation. Any other transformation? Noah, it's your turn. Vertical stretch by a factor of 2. I agree. Vertical stretch by a factor of 2 is good. Let's leave that. Did you see it when I think you probably, yeah, you probably saw it. You probably saw it, Noah. Anyway, vertical stretch by a factor of 2 is there. Anyway, let's keep going. Let's keep going. We're running out of time here. What else we got? That was Noah. Taking Noah out. Let me ask for another transformation. We have 2 so far. We have a couple more to go. Let's ask Keontae. Keontae, it's your turn. Give me another one, please. I think there are some more. Keontae, which other one do you think? Horizontal translation left by 3. I agree. I'm not going to pull that box down because y'all just peeking behind my box now. So I'm not going to pull that box down. I'll pull the box down when we got them all. So, Keontae, absolutely. Horizontal translation to the left by 3 is good. All right, so I'm going to take that. Take Keontae out. There are some more. Let's hear if the next person can get the others. I don't know if you're trying to avoid them, but anyway, Elizabeth, Liz, I think is what you prefer. Liz, it's your turn. What else you got for us? Tell us what else you think is going on. We'll use the chat as a reference list in a little while. So Liz, it's your turn. What other transformations do you see going on? Not so sure? All right. That's okay, because we're going to help you through this now. Let's focus on this negative that you see right here. Let's see if that can be one of the transformations. Let's go back to the first page, right? And see that's a K, right? Let me erase it. And look under the K and see the kinds of things that the K can do. If it's negative, what is that K doing? I leave it on that page for you to go down the page and look and tell me what you think is going on with the K. What is that K doing? The K in this case is this negative? What do you think it might mean? If you just go down the page, it will kind of give you a clue as to what's going on. There are two things that the K can do. I'm asking if you can give me one of them. Horizontal compression, you say? Okay, let's have a look here. Now, I'm going to agree with the horizontal part. The compression part is the part I'm not going to agree with you on. So you're halfway there. So what's the other option? If it's not a compression, then it's a what? Horizontal stretch. Okay, good. Hold that thought. Let me see if I can get somebody to tell us what the factor is, though. So I'm going to take Elizabeth out for now. So there's a bit of a trick to it when it comes to horizontal. It's always a little backwards, like I said. We're going to go to Riddy on this one. So Riddy, help me out. What is the factor here? So it's a horizontal stretch. We got that from Elizabeth. By what factor? Riddy, over to you. No, Riddy. No, no, no. Let me show you again how the K works. Go back to that first page. See what I said there? 1 over K. The factor is always 1 over whatever that number is. Okay? So let's try again. Okay, back to the equation. There's the equation. What would you say is the factor for this horizontal stretch? So Elizabeth is right. It's a horizontal stretch by a factor of what, though? Well, it's a factor of 4. Let's just go with that. I wouldn't call it a factor of -4. The negative does something else. In the interest of time, so, okay, I see what you're saying, Elizabeth. It's a factor of 4, though. Don't say -4, say 4. But what does the negative part do to what kind of transformation does the negative do? Anybody, just put that in there quickly. What is the negative doing? A reflection on the y-axis. That is correct. That's exactly right. So now I'm in a position to reveal everything, okay? So vertical stretch by a factor of 2, reflection on the y-axis, horizontal stretch by a factor of 4, not -4, but +4. Horizontal translation left by 3, somebody gave us that earlier on, and vertical translation down by 8. We got all of those things. So those are all good to go. Now the question is, what happens to our x's? What happens to our y's? Remember, I'll tell you the things that are going to affect, in fact, one of you tell me which one of these is going to affect the x. Tell me all the things that are going to affect the x, are going to affect the x, right? So Ryland and County, yes, it is a reflection on the y-axis. I agree with that. And Nicholas said it as well. Axel said it as well. Of these things, which one is going to affect the x? So we need to work on our x's now, right? Is it number 1, 2, 3, 4, or 5? Which one is going to affect our x value? 1, 2, 3, 4, or 5? The horizontal stretch and the horizontal translation? You're right. So these affect the x. Anything else affect the x? And the reflection, yes, the thing that is reflected across the wax also affects the x. So here's what we're going to do now. We're going to multiply each x value by -4, and then we're going to subtract 3. Okay? So what I want you to do right now for me, and this is going to be your homework, is copy this table down, right? I'll give you some time to do that. There's about 4 minutes left in the class. Copy this table down. Well, you don't really need to copy the table down because this is your x squared table. So -3, 9. Copy down the equation. Make sure you know what all of the transformations are. And I want you to come up with the new x's and the new y's based on all of that. Okay? Isaac, I see you put an answer there, but I'm going to ask you to hold off on your answer. I'm going to assign this as homework. I'll take a screenshot of this. Maybe I'll put a screenshot of this in the D12. But your homework is to complete this table of values after the transformation. Take all the x's and deal with them. Take all the y's and deal with them. Okay? Figure out what happens to all the x's. Is this what we submit to the assignment as is yesterday's homework? No, I haven't told you yet which homework I'm going to be asking for. I'm going to be asking for a homework tomorrow. And so I will tell you tomorrow which homework it is. It's always a random thing. So Harish, please don't submit anything yet. Tomorrow, when we come back in, I will say, could you all submit this by the end of the day? Usually I tell you on the day, and I want it by the end of the day. So as long as you've got everything done, you have nothing to be concerned about. Okay? So when you do it, just hold on to it. Any homework that you get done for me, just hold on to it. And then I'll pick one of them and ask you to submit it. So you've got 1 mark so far, homework check mark, and that's the one that went in for the graphing assignment. This will be one of the other homeworks that you get. And I'll put this in the calendar as well. But I'm not going to put the answers in. You're going to have to fill this in for yourself. Okay, Harish and everybody else. So copy that down. There's the equation. These are your x and y values so far, original values, -3, 9, -2, 4, -1, 1, and so on. But then I have to come up with new values, and those are what are behind these blue boxes. All right, so is everybody clear on what you're supposed to be doing for this? Tomorrow we're going to be answering another question, which is, what is the image of the point 0, 0? What is the image of the point -4, 16? All image means is what happened to that point? Where did that point go? Right? These are all original points in the table, and they all have images which are behind these blue boxes. And I'm going to be asking that question tomorrow when we come in. What is the image of -4, 16? But I'm going to leave it there for today.